So we're talking about the unit circle. With the unit circle, we're going to go through an easy trick for radians. We've already gone through degrees in a different lesson. Radians, I think, are actually easier because, number one, you already know degrees. Number two, you don't have to do any thinking about is it even or odd. The only trick when you apply the hand trick to radians is if the denominator is 3, that's your index finger. If the denominator is 4, that's your middle finger. And if the denominator is 6, that's your ring finger. And then same rules for the hand trick. You bend whichever finger it applies to. That finger acts like the comma. The other fingers are the numerator inside the square root. And your denominator will always be 2 for all of those angles. So, let's actually skip to here. We're going to fill these in. Cosine and sine, remember, in quadrant 1, you always get everything's positive. And the rule is just that it's going to be your reference angle. Your numerator, since these are always going to be fractions, your numerator will always just be 1. So that's going to be like pi over 6, pi over 4, and pi over 3. In quadrant 2, where it's negative positive because you're in quadrant 2, your numerator is going to be 1 less than the denominator. Denominator minus 1. So denominator 6, your numerator is going to be 1 less. It's 5. Denominator is 4, numerator is 1 less, so it's 3. So the denominator is 3, the numerator is 1 less, so it's 2. It's always 1 less in quadrant 2. But these angles have the same denominator. They have the same reference angle. In quadrant 3, you just have to add 1 to the denominator, and that will be your numerator. And again, it's negative in quadrant 3. So add 1, you get 7. Add 1, you get 5. Add 1, you get 4. And then quadrant 4, you have to double it, so 2 times your denominator, and then subtract 1. There's an easy reason, an easy explanation for why that's what the rule is. We'll go through that in a second. But double, 12 minus 1 is 11. 8 minus 1 is 7. 6 minus 1 is 5. Double minus 1. And those are all the angles except for your x-axis and y-axis angles. Those are all your angles in radians that are on the unit circle. And then for all of these that are over 6, the reference angle is pi over 6. If they're all over 4, the reference angle is pi over 4. If they're over 3, it goes back to the reference angle of pi over 3. Which, from the picture of the hand I showed you, over 6 is your ring finger, over 4 is your middle finger, and over 3 is your index. So when you bend your ring finger, you have 3 fingers before the bent finger, so it's 3, 1. Square root of 3 over 2, 1 over 2. When you bend your middle finger, you get 2 fingers on each side, so it's 2 and 2. Root 2, root 2. And if you bend your index finger, you have 1, 3. 1 over 2 and root 3 over 2. So once you know degrees, radians should be super easy. So going back to talking about the unit circle, thinking about why the rule is what it is, and we'll fill in our x and y axis angles and all of that stuff. This is 0 radians or 2 pi. 0, 2 pi, same thing. Then if you're trying to remember which one's which, you can always apply back to your hand. You know that it goes in order, 3, 4, 6. 3 is your index, 4 is your middle, 6 is your ring, which means that this angle, the lowest angle, is pi over 6. This is pi over 4, and this is pi over 3. And then those ordered pairs that we just talked about, pi over 3 is 1 and then 3. Pi over 4 is root 2 and root 2. And then the over 6, bend your ring finger, you get 3 and then 1. You still have to apply your x and y axes the same way. This would be the point going straight out to the right. That would be 1, 0. Straight out to the left would be -1, 0. Straight up would be 0, 1. And that angle up there in radians is pi over 2. And then all the way down to the bottom, that would be 0, -1. That angle is 3 pi over 2. Those rules, by the way, the rules actually still apply. If you think about this, this is kind of quadrant 3 and quadrant 4, because it's right in between. The quadrant 3 rule is that you would add 1 to the denominator. So if you add 1 to the denominator, you get 3. The quadrant 4 rule is you would double it and take 1 away. If you double 2 and take 1 away, you get 3. Either way, you get 3 because it's in between. So that rule still works. Yeah. Over here to the left, we didn't write that one down. That's just pi. That's half the way through the circle. That's pi. By filling those in and then thinking about what we do with reference angles, this is how they are going to match up. To get back to here, these angles are the same measure. They have the same reference angle. So what you would do to figure out what this is, algebraically, mathematically, you'd go all the way to pi and then back it up by subtracting pi over 6. So think about what's going to happen mathematically there. You would get a common denominator. So you would get 6 over 6 minus 1. So the numerator is always going to become the denominator, 6 over 6 minus 1, which is why we get 5 pi over 6. Your numerator will always be whatever the denominator is minus 1 because we're subtracting the reference angle from. Because if you did this one with the pi over 4, you would get a common denominator, which would be 4 over 4, and you would subtract 1 from it. So you get 3 pi over 4. Here, this is going to be a denominator of 3 because you're subtracting the pi over 3 from it. And you subtract 1 from the numerator, it's 2 pi over 3. Filling in those coordinates, remember quadrant 2 is negative positive, so and then bend your finger that matches up with the denominator. So for the over 3, that would be your index or pointer finger. And it's negative, positive. For the over 4, that's your middle finger, and it's negative, positive. So negative 2 over 2, positive root 2 over 2. Over 6, that's your ring finger, which is negative, the ring quadrant 2, and positive. Getting your angles in quadrant 3, if you follow the same logic, we're going all the way to pi and then adding the reference angle. all the way to pi, then add the reference angle. So then we would add pi over 6. So you have 6 over 6 plus 1 over 6. You get 7 pi over 6. The shortcut's just to remember that you just add 1 to the denominator. This is over 4. This is over 3. Add 1 to the denominator, you get 5 pi over 4. Add 1 to the denominator, you get 4 pi over 3. Then fill in your coordinates. In quadrant 3, they're both negative. Over 6, that's ring finger. So bend your ring finger, you get root 3, then 1. And they're both negative. Over 4, you bend your middle finger. So that's root 2 and root 2, and they're both negative. And then when it's over 3, when the denominator is 3, you bend your pointer or index finger. So that's 1, 3. And they're both negative. Going around to quadrant 4, you would go all the way to pi and then back it up. So if it's 2 pi, getting your common denominator, you would multiply. That's why the rule was double minus 1, because you're doing 2 pi minus the reference angle. So you double and then minus 1. So the reference angles, 6 is always the closest, 4 is always the middle, 3 is always the furthest. And then your numerators, double minus 1, so that's 6 minus 1 is 5 pi. Double minus 1, that's 8 minus 1 is 7. Double minus 1, that's 11. And using the finger trick, you get your coordinates. Over 3, you bend your index, so that's 1 and then a 3, root 3. In quadrant 4, it's positive, negative. Bend your middle finger for the over 4, you get root 2, positive, negative. And then over 6, that's bending your ring finger, which is root 3, and then 1, positive, negative again. So let's do a quick summary just about reference angles. Just for reference angles, because reference angles will tell you which finger to bend, so this takes care of degrees and radians. In degrees, the reference angles were either 30, 45, or 60. The trick for degrees was if the tens place is odd, and it matches up with the 30. And 30 is your ring finger. If it ends in a 5, the ones place is a 5, the reference angle is 45, it matches up with your middle finger. And if the tens place is even, the reference angle is 60, and that matches up with your pointer finger, your index finger. But those are your 3 reference angles, 30, 45, and 60. For radians, it's actually even easier. All you got to do is look at the denominator. If the denominator is 6, your reference angle is pi over 6. If your denominator is 4, the reference angle is pi over 4. If the denominator is 3, the reference angle is pi over 3. All you got to do is look at the denominator. And then again, pi over 6 goes with your ring, pi over 4 goes middle, pi over 3 goes to pointer or index. Then the last big thing, we have it written right here for quadrants. Quadrant 1 is always positive, positive, negative, positive, negative, negative, positive, negative, going around the quadrants. In radians, quadrant 1 would just be your reference angle, so like pi over whatever. In quadrant 2, it's going to be denominator minus 1 will be your numerator. Quadrant 3 is denominator plus 1. And then quadrant 4 is 2 times denominator minus 1. in degrees to know which quadrant it is if it's between 0 and 90. 0 through 90, you're in quadrant 1. 90 through 180, you're in quadrant 2. 180 through 270 degrees, you're in quadrant 3. And then quadrant 4 is 270 degrees through 360 degrees. So you know which finger to bend, which quadrant you're in, you can figure out the coordinate for degrees or radians.